This is the screencast for Lesson 39 in Stephen C# 24-Hour Trainer. This lesson was about graphics programming. In this try it, we're going to build this little application that draws a simple line graph. Here's the program. Right now all it has is a picture box and it doesn't have any code. We want to do the drawing for this thing in the picture box's paint event handler. So I'll click on it, go over to the properties window, click on the events button, find the paint event handler and double click. So here's our event handler. The instructions said that this event handler should create some data and then invoke a draw line graph method, which we'll write in a minute. So let's make some data. I'll call it values, and we'll just type in some values here. Okay, and now we'll call our draw line graph method. I'm going to pass into this method the graph picture box, the graphics objects that we're going to draw on, and the values. To create this thing, I'm going to right click on the method and say generate method stub and let Visual Studio do my work for me. Get rid of that exception. You can change the names of these parameters if you like. These are good enough, so I'm just going to leave them alone. Now, if you want to take advantage of a graphics object's smoothing methods, often you want to do that right away so you don't forget, and everything you draw afterwards is nice and smooth. So I'm going to say graphics.smoothing mode equals anti-alias. That will make nice smooth lines for our line graph. And I'm going to say graphics.text rendering hint equals anti-alias grid fit. That usually makes text nice and smooth. Now, before we do our drawing, we need to know a little bit about the geometry here. We need to figure out what the drawable area of the picture box is, and I want to add a margin so text and things don't get too close to the edge. So I'm just going to make these constants. I'm going to call it margin x equals 15 pixels. So that'll be our x margin. Margin y equals 10 pixels. That'll be our y margin. Now we also need to know how big the area is that we're allowed to draw in. So I'm going to create some variables for that. Width equals graph picture box dot client size dot width minus 2 times our margin. And I'll do the same thing for the height. Minus 2 times the vertical margin. All right, so there's our, now we understand where the drawing area is. The next thing we want to do is create some scale factors so we can stretch the values in the values array out so that they fill this drawable area nicely. So first, let's figure out how to do that horizontally. I'm going to say float scale x. This will be our horizontal scale factor. I want to take the values in the values array, their horizontal positions, their x positions, are going to be the same as their indexes in the array. So it's going to be 0, 1, 2, 3 through however many there are in there. For example, if there are 10 items in the array, then these values will go from 0 to 9. That means we have the area where the values we're trying to draw go from 0 to 9, and they need to cover the drawable area of the picture box, which has size width, this variable here. That's why we created it. So what we want is float scale x equals width divided by the number of values in the array. Length minus 1. Okay, the vertical scale is a little bit more confusing because we don't know what the biggest value in the array is. In this case, I'm assuming that the array has values between from 0 and larger. I'm not going to deal with negative values, and you'll have to change this code if that's what you want to do. But I'm not going to assume that this biggest value is 100. In fact, let's just change it to 70 for now. So I want to find out the biggest value in the array and use that to scale vertically. So I'm going to say float scale y equals the height. Okay, this corresponds to using width here, divided by, now we need to know what the biggest value is. Well, there's no real reason for us to have to calculate that for ourselves. We can say values.max and let the max method figure it out for us. So those are our scale factors. The next thing we need to do is we want to create variables x0 and y0 to keep track of the last point we drew in the graph. Then when we get to the next point, we can use the previous point to connect them so we get a line. So I'm going to say float x0 equals wherever we should put this point. Well, when we draw one of these points, it's going to be at position margin x plus scale x times the value, the index of this value in the array. So it's x value. So that's going to be, as we loop through the array, it's going to be 0, 1, 2, 3, and so forth. For the first point in the array, it's 0. Now, obviously scale x times 0 is 0, so I could take that point out. I'm going to leave it in just so that the format is more similar to what I'm going to use later when I'm in the loop. The y0 value is a little bit stranger because picture boxes measure with 0, 0 in the upper left corner, and y values increase downward instead of upward like we normally think of when we're drawing graphs. So what I need to do here to get the right value is I need to make this thing the graph picture boxes client size dot height, so that says start at the top of the picture box minus the margin minus scale y times the value. The value for the first point is values of 0, so that's why I'm putting it here. So what this y coordinate means is go to the top of the picture box, move down by the distance of the margin, and then move down by this value times whatever, times our scale factor. All right, so that's x0 and y0. Now we can start looping through this array. So I'm going to say for int I equals 0, I less than values dot length I plus plus. And now I'm going to find the coordinate of this point and then draw from here to the previous line. So I'll say float x1 equals the coordinates of this point. Well, what is that? It's the same equation we used up here. Let me just copy and paste them down here with just a couple changes. Instead of scale x times 0, I want scale x times I. So for the first point it'll be 0, for the second point it'll be 1, and so forth. And here, instead of multiplying by values of 0, the first value in the array, we're going to multiply by the ith value in the array. So those are the coordinates of this next point that we're dealing with. So now we can draw a line. Let's do it. Graphics.draw a line. Here I'm the pen. I'm going to use a stock black pen. Pens.black. And then the coordinates of the points, I'm going to use this overloaded version. So I'm going to say x0, y0, x1, y1. So it'll connect those 2 points. And then there's some other stuff to do, but down at the end of the loop here, I need to update x1 and x0 and y0 so that they point to this point, this x1, y1, so that next time through the loop, that's the previous point. So I say x0 equals x1, y0 equals y1. Now let's run the program and see if we get a graph. Hopefully we get something vaguely reasonable. Let me go back up here to the data so we can compare it to the graph. It starts out small at 15, goes up to 65, goes even higher to 80, down to 40, up to 70, down to 35, and up to 90. 90 is right near the top edge, right? That's where our margin is. That's the largest value in the array, so that makes sense. Real quickly, let me go back and change this 70 back to 100 and run the program again. And because of the way we calculated the scale factors in the code, it's changed the scale so that now this value 100 is now up at the top margin. The value 90 is a little bit lower. All right, so that's most of what we need to do. The only other thing we need to do is display the values in text. And the instructions said if values of I is greater than or equal to 50, then we do one thing, else we'll do another. So if values of I is greater than or equal to 50, I want to draw the text a little bit above the point. So I'm going to say graphics.drawString. Now the text I want to draw, that's values of I, and I need to convert it into a string using toString, comma, the font. Well, I didn't build a font for this program. I'm just going to use the one the form is using. So I'll say this dot font. A brush, I'm going to use the stock black brush. And then finally, the point where we want this thing to be drawn, that's simply x1, y1, the point that we've drawn on the graph. Because the instructions say to move it up a little bit, I'm going to subtract 12 from y1, so the point will be moved up. Remember that y values increase downward, so subtracting from y moves the point up. Now, if the value is not less than or equal to 50, we'll do almost the same thing, except we're not going to move the value up. And I'm going to change this to a red brush. You won't be able to tell in the book, but you'll be able to tell when you watch the screencast and if you run the program yourself. So now you can see, if the value is greater than 50, it's moved up a little bit above the point. There's the point. If the value is less than 50, it's drawn below the point. The coordinates of this point you use in the drawstring method give the coordinates of the upper left corner of the text. So for example, here, that point right there is the upper left corner of this text, 40. And that's all there is to it. Let me show you one more thing real fast. Because of the way this routine creates its scale factors at runtime, if I change the size of the form, notice that it rescaled the graph so it still fits. If I make the form tall and skinny and run it again, it will resize the data so that it fills the form nicely.